What we have here, guys, is we have question 3 and 4. What I'd like me to do is, it'd like me to get express C in terms of A, B, and D. So we have A over B equals B over C plus D over nothing. Now, what will come in quite handy is if everything had the same denominator. If every fraction had the same denominator. So we discussed that the other day. Remember I asked you how do you do a half plus, I don't know, 3/4. We'll do 3/5 just to make it more generic. What you'd say is the 2 looks over at the 5 and goes, okay, if I have a 5 top and bottom, that'll give me a common denominator of 5 over 10. And if the 5 looks at the 2 and goes, oh, I'll have a 2 top and bottom, that will give it 6 over 10. And all of a sudden it's compatible through addition. You're going to do the same thing here, okay? So what you're going to do is you're going to look across and the B will go, look, if I had a C, everything would be cool. So B, C top and bottom. C looks over at the B and goes, if I had a B top and bottom, that'd make everything pretty easy. The D looks over as well and goes, well, I don't have a B or a C, so look, I'll take both. That makes sense? Now what happens to the bottom now? It'll cancel because it's all the same thing. In the same way, a half plus, in the same way, a third plus, 7/3 equals 8/3. See the way I can just get rid of the trace and it maintains its balance. That's what we're doing here. We're just getting rid of the denominators because they're all the same. We're now going to get AC equals B squared plus, I'll do it in alphabetical order, BCD. Which letter do I want on its own? C. Where's the C's located? It's in there, okay? Now, to move these, I have to move, the C is locked in by the B and D. The C has been multiplied by the B and D, so I have to move everything over to one side. So here's what we're going to get. AC minus BCD equals B squared. So see the way the C is still locked in there. Can anybody suggest a way to get the C out of there? Factorize. C multiplied by what gives you AC? A. C multiplied by what gives you BCD? BD. So C, when you multiply it by A minus BD, gives you B squared. How do you get C on its own? Where does the A minus BD go? Underneath an A minus BD. Is that alright? Okay, we try another one now. Same deal. Okay. We look across and what we see is question 4. And question 4 has a look and R has nothing underneath it. And you have a Q squared. Now remember what I always say, is it fully factorized or not? Is another question we always ask ourselves. Is everything fully factorized here? Can we take anything out of the top? No. Anything out of the bottom? No. Okay. The R looks across and it says, I haven't got a denominator, so what I'm going to do is I'm going to take that Q plus P top and bottom. So Q plus P on the bottom and a Q plus P on the top. Q plus P cancels. Is that alright? Multiply it out. RQ, I don't know why I wrote down P. RQ plus RP equals Q squared minus PR. Which letter am I looking to get on its own? P. Anything that has a P in it goes to the left. Anything that doesn't have a P in it goes to the right. Hence the RQ will go to the right, but the PR will go to the left. Okay, so we're going to get a PR. CRP, yeah? That's the same thing as PR, isn't it? Just the opposite way around. 2 multiplied by 3, same thing as 3 multiplied by 2. So it's PR plus PR equals Q squared minus RQ. Is that right? How'd you turn 2 P's into 1? We did it earlier. We're going to factorize. I don't even need to factorize actually, excuse me. I don't need to factorize because I can add them together to get 2PR. Does that make sense? 2PR. And then I can take out q here, can't I? Q into q minus r. Now, what's stopping the p from being on its own? And 2. 2r. So, p will equal q multiplied by q minus r, all divided by 2r. Because if it's multiplied by 2 and multiplied by r on the left side of the equals, when it travels to the right hand side of the equals, it turns directly into division. Ken? You could put it as that. No, the answer is no. Both answers are acceptable. Okay? Alright. Look, what I'll do as well is I'll do one of the first ones as well, because I'm having a feeling we're a bit in the deep end here again. So I'm just going to go for number 2, just to do one extra one, okay? It's like question 2 here, because we seem to be just jumping right into it at the moment. So, question 2. What's the first thing I'm going to do here, guys? What's the first thing I've been doing in every single question since I began today? That's what the question asked me to do, but before that, denominators, q top and bottom, q top and bottom, cancel the q's in the bottom. I'm looking for q on its own. Anything with a q goes to the left, anything that doesn't have a q goes to the right. pq minus rq equals t. q bracket p minus r equals t, and then q on its own, p minus r. Alright. Now, they jazz this up a little by giving you languagey type questions, okay? So something like this. The perimeter P of a rectangle in terms of x and y. What's a perimeter again, guys? We should all know by now. What do you say? Not necessarily the area, but the length around the object. Okay, it's when you add all the lengths together. So what is the lengths together this time? 2x plus 2y. P is equal to 2x plus 2y. Get x on its own. So, bring the 2y over the other side. P minus 2y equals, I'm going to propose a spin. 2x equals p minus 2y. Does anybody know what I did there? If 2 plus 3 equals 5, 5 is the same thing as 2 plus 3. And I didn't need to change any signs, did I? No. Then what do I do with the 2? It's handy out, isn't it? Handy question. Okay. What about the next one? A cube has a side of length k. Write the surface area A of the cube in terms of k. Now, surface area is all 6 sides added together. So if you were to finish this off, I think it's something like, there you go, there, the missing sides, okay? So there's 6 sides there, isn't there? Now what's the area of one face? The front face as an example. What's the area of that? Sorry? K multiplied by k is? K squared. How many sides do we say there was again? 6. So the surface area is 6k squared. Okay. Express k in terms of a. We want to get k on its own. First thing that you get rid of is the 6. A over 6 equals k squared. What can we do next? Square root both sides, and you're going to get square root of a over 6 equals square root of k squared, which is k. Alright guys, so look, that's that one done. Looks harder than it is. This one here. Given the trapezium of sides A and B as in the diagram. Oh wait, I know I did. There we go. Given a trapezium with sides A and B as in the diagram, and given that the area of the trapezium is given by A equals A plus B over 2 multiplied by H, express B in terms of A, big A, small a, and H. Basically you want to get the B on its own. Is that right? B wants to be on its own. Just a bit about trapezium. A trapezium is an object where 2 of the sides are parallel to each other. They're separated by a distance H. To get the area of this trapezium, you always use the formula here. You'll be seeing it later on in the course, okay? But the top two of the sides have to be parallel with each other, but they can be different lengths. That's what trapezium is. Now, what we're looking at here, guys, is we're looking at capital A equals A plus B over 2 times H. Now, what happens when you multiply a fraction by a number? What happens if you multiply 7 over 2 multiplied by 5? What happens there? What's the answer to that? Can anybody tell me? 7 over 2 multiplied by 5. The answer is 35 over 2. You multiply top by top and you leave the bottom the same, because there's nothing on the bottom to multiply the bottom by. It's technically 5 over 1. So 1 multiplied by 2 is still 2. Does that make sense? So this carries true that the H is H over 1. Multiply it out and we get AH plus BH all over 2. Common denominator, 2 top and bottom. Cancel the 2's. Which letter do we want on its own? It says it here. B. So bring the AH over to your side. 2A minus AH equals BH. Huh? Spin it around, yeah, thank you. Good idea. And then what happens to the B? 2A minus AH over H. That's okay. Everybody happy with that? They're different. They're different values. Yeah, one of them's a capital A and one of them's a small a, so they're not the same entity, so they can't cross off with each other or anything like that, or you can't factorize them either. Okay, there's good thought though. Now, let's move on. Number 9. Express t in terms of x. Okay, bring the 2 over to your side. T equals x minus 2. Easy enough, right? And then what about the y? Express t in terms of y. Bring the 3 underneath. T equals y over 3. Done and done. Hence, by equating both values, what does equating both values mean? Two of them are equal to each other. T is equal to t, because it's called t and it's in the one question. Therefore, x minus 2 has to be the same thing as y over 3. Write down an equation in x and y. So it just wants an equation that has x and y in it. Give it a common denominator, lads. Multiply by 3 top and bottom, and we're going to end up with 3x minus 6 equals y, and that's your equation. Or y equals 3x minus 6. You hit the lights there again. Good man. Okay, everybody happy enough with that? Move on to another one. 11 and 12. You might think they're tough, but they're actually not. A cone has a radius r, has a height h. It has a slant height of 10 root 3. This is a 90-degree triangle. Using the theorem of Pythagoras, express r in terms of h. Okay, in Pythagoras' theorem, what goes where? It's the biggest side squared equals, anybody remember? The smaller side squared and added together. Squared first, added together second. What goes in here? 10 root 3. 10 root 3 is the biggest side. If I rotate that around, you can see that it's much bigger than h. Yeah? So, 10 root 3 squared. What goes here? h or r, doesn't matter which one. The main thing is the longest side goes in on its own. 10 root 3 squared, 10 by 10, 100, root 3 by root 3 is 3. It's going to be 300. Now we want to get which letter on its own? R on its own. So where does the h squared go? 300 minus h squared equals r squared. And then finally to get r on its own, and we tell me the last step. Square root both sides. We get 300 minus h squared. Square root both sides. Any questions? We're good. Okay, last one, number 12. Okay, we're doing alright in time. 12. A squared equals B squared plus C squared minus 2BC cos A. Which one are we looking to get on its own? Looking to get cos A on its own. Okay, so here's what we're going to do. We can bring this, the full thing, over the other side. And we can bring the A squared to the right. So what happens when minus 2BC cos A travels across? It changes from... What happens if I was to bring something like 3xy from one side to the other side? What would happen to it? Minus 3xy. Same thing. So it's going to be 2BC cos A. It simply changed from minus to plus. What about the other parts? Anyone want to tell me? Excuse me.